Okay, so now we're going to move into actually putting our rational functions on graph paper. So at the top here, it's just a reminder of what we're going to do when we're graphing rational functions. We need to sketch our asymptotes with dashed lines. This is the framework for our graph. It's not part of our graph. Therefore, solid lines are not acceptable. We're going to plot any intercepts that we find. Holes we're going to also graph, and we're going to graph them by showing open circles in our graph. Remember, a hole means that there's nothing there, but we need to see that there's physically nothing there by having an open circle there. Then, after you're done graphing all of that information, you're going to find at least one point on each side of the vertical asymptote that's going to help us create the graph. If there's a hole on one side of the vertical asymptote, you can use that as your point to help you create your graph. Okay, so let's get started. Remember, the first part says find the domain. This must be done first, okay? So are there any restrictions on my first graph here? There's a denominator. Denominators can't be 0. So x can't be 0. So if I want to write that in interval notation, I'm going to say that my domain is from negative infinity to 2, union 2 to infinity. So denominators can't be 0. So I said x can't be 0, I think, on accident, but I meant x can't be 2, right? Because if x minus 2 can't be 0, and I solve that. Okay, now I'm going to find any holes. So I look to see if my fraction's simplifiable. My fraction will be simplifiable if I can cancel out common factors. If you look at both the numerator and the denominator, neither one is factorable, and they don't have any common factors. So therefore, there are no holes in this graph, none. X-intercepts, I set y equal to 0 and solve. The shortcut is setting the numerator equal to 0 and solving for x. There is no x in your numerator, so there's no x-intercepts. Y-intercept is always 0 comma something. So it's 0 over and then, 0 comma and then plug in 0. You have 4 over negative 2, which is negative 2. Vertical asymptotes, set your denominator equal to 0 and solve. You get x equals 2. Horizontal asymptotes, compare the degrees. Here the degree in the denominator is bigger. When the degree in the denominator is bigger, it's y equals 0. And now it says sketch a graph of the function. So what I'm going to do is I'm going to attempt to graph my vertical asymptotes and horizontal asymptotes and any holes in red. And then I'll graph anything else in a different color. Because anything that's going to be graphed in red is not actually part of my graph. Is it mandatory to switch between colors? Absolutely not. Okay, so I'm going to start by graphing my vertical and horizontal asymptotes. X equals 2, vertical asymptote. Remember, it has to be dashed. And then my horizontal asymptote, y equals 0. I did forget to mention that it says sketch the graph for G, and then H says the end behavior. We will be able to do end behavior before we even sketch, but right now we can't because we have to look to see what it looks like to get the end behavior. Then we're going to be able to say like, oh, okay, I know how to figure out the end behavior. Okay, I'll also graph the holes in red, but there aren't any, so I'm going to switch back to blue and then graph the rest of the graph. So any x-intercepts and y-intercepts. There are no x-intercepts. It should make sense why, because there is a horizontal asymptote there. Y-intercept is at 0, negative 2. So far, I have enough to graph the piece that's to the left of the vertical asymptote. So I'm just going to go ahead and connect these, put arrows gliding along that asymptote, along that one. Now I need my other hyperbolic branch. Okay, so it is to the right of my vertical asymptote, and I have to figure out where it is. So I'm going to plug in a value to the right of my vertical asymptote. 3, 4, 5, 6, 7, 8, 9, or 10 are all options. I'm going to plug in 3 because, hey, why not? So, table of values. Please make sure you make a table of values so that we can actually grade that point, or write your point down somewhere so that we can grade it and we don't have to search the graph for the point that you got. I'm going to plug in 3 for x to see what we get for y. I get 4 over 1, which is 4. So now I know there's a point at 3 comma 4. Oops, that's not 3, 4. 3 comma 4. And then now I can graph this branch 2 right here. And there's my 2 branches. Okay, Let's describe the end behavior in limit notation. So I'm going to say the limit as x approaches negative infinity of my function, which was named f of x, is equal to. So as my x values get smaller and smaller and smaller, what's happening to my y values? They are leveling off, right? So they are leveling off, and where are they leveling off at? They're leveling off at 0. So I'm going to say that the end behavior here is, oops, that's not a color, that's 0. Notice I copied and pasted because I just wanted to save a little bit of time right there. So now the limit as x approaches infinity of f of x is, if you look to the right, where your x values are getting bigger and bigger and bigger, your y values are leveling off at 0 also. So what you should notice is that with rational functions, we are going to have a horizontal asymptote a lot of times. If there's a horizontal asymptote, your end behavior has to get closer and closer to it. So we could get our end behavior before we even graph. We're going to try that on the next one. Okay? All right, here's our next one. Find the domain. Always has to be done first. There is a denominator. Denominators cannot be equal to 0. So I'm going to start off by saying that my denominator, x squared plus 5x, cannot be 0. And now I have to solve this. This is a quadratic with an x squared and an x. So I'm going to try to solve it by factoring. In order to solve by factoring, it has to be equal to 0, which it already is. Next, I look for a GCF. There is a GCF of x. And now I can say x can't be 0, x can't be negative 5. I can think about what this looks like, or I can draw a picture if I need to. If you still need to draw a picture, there's nothing wrong with that. Negative 5 here, 0 here, can't be, but could be anything less than that, anything in between, anything more. So my domain is negative infinity to negative 5, union. Negative 5 to 0, union. 0 to infinity. You could also always check your domain after you're done graphing. If you look at the first graph that I did, it goes from an arrow to an arrow, except there's nothing at 2. So I can get my domain that way. Okay, next it says find any holes. So to find any holes, I need to see if it is factorable and then common factors cancel, or it could already be factored for me. Okay, so let's write this down. The denominator, remember, is factorable. So I have g of x equals. My numerator is not factorable, but technically you have to realize that it is 2 times x. So like you could technically factor it to 2 times x over, and then this was x times x plus 5. So are there any common factors from numerator to denominator? The answer is yes. Remember, factors is another word for multipliers. So this is 2 times x. So technically, this is the same as what I just had written down. Okay? So the x's do cancel. This x and this x, because they're common factors. So there is a hole in the graph. Okay? So what did I just cancel out? I canceled out this x right here, and there would have been a vertical asymptote at x equals 0 and x equals negative 5, but there isn't a vertical asymptote at x equals 0. There's a hole there. So I'm going to say there's a hole at 0, comma. I'm going to switch back to blue. Oh, actually, I can keep it in red. 0, comma. And then I have to plug it into my simplified function. So I'm going to write my new simplified function, g of x equals 2 over x plus 5. And then I like to put this cloud around it so that my eyes gravitate toward it and I never look back here again, ever. Okay? All right, plug in 0 and you get 2/5. So there's a hole at 0, comma 2/5. X-intercept, set y equal to 0 and solve. When it's a fraction, shortcut is setting the numerator equal to 0 and solving for x. I can't set 2 equal to 0 and solve for x, so there's no x-intercept. Y-intercept, plug in 0 for x and see what you get for y. I get 2/5. Now, I should be saying to myself, that sounds familiar. 0, comma 2/5. Didn't I just hear that? Yes, I did. There's a hole at 0, 2/5. So there's actually no y-intercept. It's because this is a whole. Vertical asymptote, set your denominator equal to 0 and solve. You get x equals -5. Horizontal asymptote, compare your degrees. Your degree in the denominator is bigger, so y equals 0. And then once again, I can do end behavior right now. I can do, is this still my paste? Paste, yes. I'm going to put this one here too, paste, yes. The limit as x approaches negative infinity of, is this one called f of x? It's called g of x. Not a big deal. I can change that to g. G, get rid of that negative right there. Here we go. Is, and remember it has to approach my horizontal asymptote. So I'm going to say 0 and 0 here. Now if I wanted to wait until I was done graphing, you can. It does not, it's not a big deal. Okay, I'm going to graph my vertical, horizontal asymptotes, and I'm also going to graph any holes in the graph right now. Okay, vertical asymptote, x equals -5. Horizontal asymptote, y equals 0. All right, there is a hole at 0, 2/5. 0, 2/5, which is about right there-ish. All right, I'm also going to graph any X-intercepts and any Y-intercepts. I'm going to change back to blue to do this because they're part of the graph. Everything in red's not part of the graph right now, right? They're just framework for it. There are no X-intercepts, no Y-intercepts. So I need to see what I can do. So to the left of the vertical asymptote, I don't have any points, so I'm going to have to make a table. An x value to the left of the vertical asymptote, I'm going to do -6. And then once again, I'm plugging it in here. Okay? That's 2 over -6 plus 5 is -1. So that's -2. -6, -2, there's a point. And then I'm going to follow my asymptotes. Now, I could plug in -4, which is to the right of the vertical asymptote, but I already know that there's a hole in the graph right here, and that means that my my branch has to be in that sector right there. But once again, if you want to plug in -4 and see that you get, let's see, if I plug in -4, I get 2 over 1, I get 2. So if you want to graph that extra point just to make sure, you can, but once again, it's not required, okay, because you already have that hole over there. Okay, let's move on to the next one here. So same process over and over again here, okay? Same exact process. So first thing, domain. I'm going to find anything x can't be. So denominators can't be 0, x squared. I'll just do that off to the side again. X squared plus, I forgot what it was, plus x minus 6. Can't be 0. I'm going to factor this. X plus 3 times x minus 2 can't be 0. So x can't be -3. X can't be +2. And now I'm going to write that in interval notation. And once again, if you want to do a sketch of it, that's fine. If you don't need to do one, then don't do one. But you could, what you should do is you should check to make sure that your domain is right after you're done graphing. I didn't do it on the last one, so let's go back. It says that it's everything but -5 and 0. And if you look, there's a vertical asymptote at -5, and there's a hole at 0. So I did it correct. Okay, are there any holes? So if there are holes, there will be common factors that cancel from numerator to denominator. So I'm going to put h of x equals. My numerator is factorable. It's a difference of squares. It factors to x plus 2, x minus 2. And then my denominator I already factored. It's x plus 3 times x minus 2. So there is a hole. There's a hole in the graph at 2 comma. And then once again, I'm going to write my new function, h of x equals x plus 2 over x plus 3. I put a little cloud around it to say, hey, eyes, look here. Don't ever look back up at this. Okay, so I'm going to plug in 2. If I plug in 2 in the numerator, I get 4. If I plug in 2 into the denominator, I get 5, so 4/5. 2 comma 4/5. All right, now I need my X-intercept. X-intercept shortcut is set the numerator equal to 0 and solve. So if I set the numerator equal to 0 and solve, I get x equals -2. So there is an X-intercept at -2, 0. Y-intercept, plug in 0 for x and see what you get for y. In my numerator, I get 2. In my denominator, I get 3, so 2/3. Remember, if the fraction's simplifiable, you need to simplify it. Neither of these fractions were simplifiable. Next is vertical asymptotes. Sets your denominator equal to 0 and solve. Notice I don't even have the original equation like in my site right now. I'm looking at the one that I simplified. So my vertical asymptote, denominator equal to 0, I get x equals -3. Horizontal asymptote, compare the degrees. The degrees are the same, so it's a ratio of the leading coefficients. The coefficients are 1 and 1. So y equals 1/1, which is 1. I can do end behavior now, or I can do it when I'm done. I'm going to do it now because I know it has to follow the horizontal asymptotes. So I'm going to go ahead and paste again, and I'm going to change the name because it's not f of x for this one and get rid of that little negative right there. This was h of x. Okay, so I have to glide along my asymptote and get closer and closer and closer to it, and it's my horizontal asymptote I'm getting closer and closer to. So that's 1. Once again, you can do that when you're done. I like to do it before so that if it was a question, let's say on multiple choice, and it asked me for a horizontal asymptote and I didn't have any graph paper, I would know, or sorry, if it asked me for the end behavior, I would know it's the same as the horizontal asymptote if I practice this way. Okay. Starting to graph, I have x equals -3 for my vertical asymptote. Horizontal asymptote, y equals 1. Any holes? Yes. 2, 4/5. 4/5 is a little bit less than 1. So like here-ish. Right, it's below that horizontal asymptote though. Okay. So now I'm going to switch to blue because those are things that are framework. They're not actually part of my graph. I just use them to help me graph. I have a y-intercept at 0, 2/3. 2/3 is a little bit less than 4/5. So it's a little bit lower than that one. And my x-intercept is -2, 0. So right there. So if you look to the right of my vertical asymptote, I actually have 3 things that'll help me graph. Right? But if you look to the left of my vertical asymptote, I don't have anything. So I have to make a table of values. And I have to plug in a value to the left of my vertical asymptote. I'm going to plug in -4. So I have -4 plus 2, which is -2, over -4 plus 3, which is -1, and that's 2. So -4, +2. And there's that piece right there. Okay? All right, the very last one, you can go ahead and pause the video and try this one on your own and then just fast forward to the end to see if you did it right. Okay, but I am going to walk through it in case some people need help. Domain, x squared minus 2x minus 3 cannot be 0. That is factorable. X minus 3 times x plus 1. So x can't be 3, x can't be -1. So my domain is -infinity to -1. Union, all values in between -1 and 3. Union, all values greater than 3. All right, are there any holes? Well, we already know my denominator is factorable. Is my numerator factorable? This is where people say no, because they forget to look for GCFs. There is a GCF, it is factorable. So I'm going to put j of x equals. There's a GCF of 3, so I'm going to factor that out. And then my denominator is x minus 3 times x plus 1. So there is a hole at -1, comma, and I'm going to write my new function, j of x equals 3 over x minus 3. Okay. All right, so notice, once again, I got that out of my site. All right, I'm going to plug in -1. I get 3 over And then -1 minus 3 is -4, so -3/4. X-Intercepts, set your numerator equal to 0 and solve is the shortcut, but I can't solve for x if there is no x, so there's no X-Intercepts. Y-Intercept, plug in 0 for x and see what you get for y. You get 3 over -3, which is -1. Vertical asymptote, set your denominator equal to 0 and solve. You get x equals 3. Horizontal asymptote, compare your degrees. The degree this time, the denominator is bigger, so y equals 0. And then once again, I can do my end behavior right now because I know what my graph is going to follow. Let me delete that negative right there. What's the name of this one? J of x. So I'll change that to j. And I know that I have to follow my horizontal asymptotes. This is going to be 0 and 0. All right, I'm ready to graph. I'm going to switch to red to graph my vertical horizontal asymptote. Vertical is x equals 3, so I'm going to do a vertical line at x equals 3. Horizontal asymptote is at y equals 0, so I'll do a horizontal asymptote there. I'm also going to graph the whole at -1, -3/4. So here-ish. Okay. All right, so now I'm going to switch to blue because I'm going to actually graph the function right now. To the left, I have enough information, but I also realize that I have my y-intercept that I didn't graph yet. My y-intercept is 0, -1. So still to the left of the vertical asymptote, I have enough information I can connect those. Notice I'm skipping over the hole when I'm drawing that, right? I'm not going through the hole. There's nothing there. But I don't have anything to the right of the vertical asymptote. So I'm going to make a table of values, x, y. And I'm going to plug in 4. So if I plug in 4, I get 3 over 1, which is 3. So I have the point 4, 3. Graph that point, and then you can make this hyperbolic branch. And there's your graph. Okay, that's it for today. You can go ahead and get started on